Does anyone have any questions from previous classes? Okay. Well, if there's no classes, we can get started. So today we're gonna, now that we've gone over some of the basics of programming in Python, now we want to make something useful, something that may be of use in your research. And so I think we talked about previously how we're playing on with the sequencing data sets that we've run. Say you have a bunch of gene IDs for your expression table, but you want to convert all those items to gene names, then you'd be able to do that. So we're gonna focus on making a tool that could be applicable to your day-to-day research. And at the end, we'll talk about how do you make that code functional where you can reuse it, and kind of getting at that idea of reproducibility in science and making it possible for others to get the same results as you, basically. So, and we've talked about this a little bit, but I think this is going to take on a slightly different meaning when we talk about modularity and kind of breaking up modular units of code into functions. And so the idea is to be able to break down a complex task into the simpler component parts. And this is, I mean, one, it's useful for organization, but two, if you need to go and debug your code, it makes it easy to kind of isolate a malfunctioning part of the code. And then also if there's one of these more simple units, these functions, maybe there's something like you're reading in a file that you might want to do multiple times in a script, then you can just call that function each time instead of having to write out the whole function every time. So when we are converting data frame rows or converting the gene IDs from that data frame, we're going to need to start with two inputs, which is that GTF file for the organism that we've been downloading from Ensemble. And then you'll need the gene expression data table. And then with these components, we're going to want to import the GTF. We're going to want to import the data table. We're going to want to extract the gene name or gene IDs with their matching gene names from the table. Map those gene names to the gene IDs in the table, and then output that modified table. And so I think what I'm going to do today is kind of go through an example. So I'm going to go kind of function by function how I would break down each of these parts and just kind of demonstrate. And then at the end, the goal will be to make your own gene dictionary script for your organism of interest, and then be able to run that code as an executable. And this code is already online on the GitHub repository, so you can use it as a guide. But I think it's important to practice writing this on your own and figuring out if you can break down the task into those component parts and then be able to construct the functions that are needed to achieve that goal. So normally when I am building a script, I like to start out by importing any external libraries. And so 2 libraries that we're going to be using to perform this task is the sys library. So this is going to interface with your system, your computer. And then the pandas library, I think, was everyone here when we went over pandas library, or do we need to talk about installing that real quick? Okay. Well, just as a reminder, if you don't have it yet, you can just download pandas through Conda. And then you can import pandas. And one nice thing about when you're importing these functions is you can give each library a nickname if you want. And so the common abbreviation for pandas is just PD. And so you can just say import pandas as PD. And so every time we call the pandas library, we need to reference PD. Whereas if we're referencing the sys library, the system library, then we have to reference it as SYS. Another thing that you can do at the beginning is set global variables, so things that you will want to reuse over and over again. So here I'm just listing the columns where I'm going to find the necessary data in the GTF file. So maybe I should have one of these pulled up. I can see if I have one real quick. Let's see. Okay. So so we're looking at, so we want just the gene records where we can, like, we don't need for every gene to find the gene name and gene ID pair. We don't need all of the smaller records. We can just stick with the gene. Whereas if you wanted to make maybe like a transcript ID to gene name reference, you might want to grab just the transcript records. But we're going to get this metadata from this column, which this is 1, 2, 3. But if you'll remember in Python, when you're counting, you start at 0. So this is really going to be column 0, 1, 2. So that's where this is coming from. And then the metadata column where the gene ID and the gene name, all that information is found, that's going to be in column 8. And then if we want to be able to, in the command line, basically write a script where we can say Python script.py, and then we want to be able to feed in variables through the command line, we're going to access those through this sys.argv. So in this case, I would want the GTF file and the tab separated file. And so those are just indicated by spaces for each argument. And those will be read in order. So one thing I can do with this function, so I don't need to worry about any inputs at this point, but at the beginning, I want to do just kind of a sanity check. I want to make sure that there are, in this case, actually 3 arguments, because argument 0 is the script name. And so this would be argument 1, this would be argument 2. And then that will be read into an array that is a length of 3, 0, 1, 2. So I want to make sure that there's 3 elements in the arguments. And if not, I can use this function where I say raise exception. And so basically when I do this, this will exit the script and provide some feedback to the user saying, hey, I'm quitting, and this is why I'm quitting. So then what I can do too, and this is just optional here, but I just printed out the script name and then print out the options that the user read in just to kind of organize stuff and let the user know what is being run. And then we can give these more, I guess, meaningful variable names. So I'm going to call this first one the GTF URL. So that's the full GTF path in the file system, or the local if you're running the script locally and the files are also in the same folder. So that first one would be the GTF, and then that second one would be the data frame or DF URL. And then I'm going to return these at the end. So if I want to run this function and get these two URLs as variables within Python.
Is there something else I can help?
Oops, sorry. Python, so then I would call this function as GTF URL, comma, DF URL equals, I think it was parse args. And so this would then read in those two files that the user input to those two variables. And so this is the formatting that we'll be using for each function that we'll write. But at the end, we'll kind of piece everything together and format the script so it can run all these things in order. Okay, so now the next steps that we want to do are read in the actual data in a format that we can use in Python, and not just have the file name. And so I'm going to make a different function for reading in the GTF and reading in the data frame, because the formatting of these files are going to be slightly different. And so here you can see, here's my comment saying what's going to be done. Here I'm defining the function. I'm going to call it read underscore GTF. And it's only going to take one input, which is that file name of the GTF. And then if you'll remember from when we talked about using pandas to read in a data frame, we'll use this read underscore CSV function from the pandas library. And if you want more information about this, you can just look at the documentation online, which will go through all the different options that you can use. And at the end, it will also give you some examples about how to use the function. So some, I guess, distinctions though with the GTF file. So remember at the top of the file, so we have these comment lines, and so these are only one item, and so that's going to mess up the counting of the columns because it's expecting 8 columns per row, or I guess 9 columns per row. And so we want, when we read in this information, we want to ignore these lines that are comments. And so each of these start with the pound sign, and so we can say the comments are equal to pound sign there. And there are no column names here, so we're going to set header equal to none. And then this low memory equals false. So this is basically, this will, when you're reading in a data frame, it will place memory limits. And so if you're reading in a really big GTF file, like from human, you may run into some issues unless you set this option to false. And then at the end, we will return the GTF. So that's that GTF file read into a data frame format. So when we're reading in that data frame path, it's going to be very similar, where we're reading in the URL. Again, we're specifying that it's a tab delimited file. We do not need to set header equal to none because we do have column names there. But since we have row names in the table, we're going to set column 0 equal to those row names. And at the end, we'll return that data frame. So let me pause here real quick and just see if anyone has any questions so far, or if anything's unclear about how I'm setting these things up. Okay. Okay, so now we have the GTF and the data frame read in as variables. And so now if you'll remember kind of our workflow is we need to make that gene dictionary. We need to map the gene dictionary to the data frame, and then we need to output that. So step one will be to take that GTF and make that gene dictionary. And so here I initialize the function, and as that first input, I want that GTF data frame that we read in the previous function. And you'll notice here, so I have a second variable that I input, but this one I have it, the variable name equals, and then some variable. So here I'm setting a default value. And I don't have to, when I call this function, I can just call make dictionary GTF, or I can call make dictionary GTF comma type ID equals something else. And so maybe I wanted to here only get the columns that were equal to transcript. I could optionally provide this variable to use gene. But if I don't provide this, then it will just use gene as that variable. Whereas with GTF, that doesn't have a default value set. So it's going to require at least one variable that it's going to use as the GTF variable. So whenever you manipulate data frames, it's a good idea to make a copy of the data frame, because sometimes when you're making some modifications to the data frame as an intermediate step, it may overwrite the original data frame. And so I like to just at the beginning make a copy of this and then only modify the copy so that it prevents accidentally mutating that original variable in case I need it for something else. And then here, I'm going to just restrict the data frame to the rows where that column 2. So remember, we set that type call variable equal to 2. So it's going to say, basically within the GTF, this dot loc is saying, give me all the rows where the GTF column 2 equals to, in this case, gene. How we set that there. And so once you run this, it's going to, basically your GTF underscore C, that is going to just give you rows where column 2 equals gene. So now we want to separate out the gene ID. So we just want the things in between the quotes here. And then we want the things just between the quotes for gene name. And so this is going to be a 2-step each step where, so I'm going to make a new column. So here I say GTF underscore C, and the bracket says, you're basically referencing a column of the data frame. Whereas if you were to say, in this case, GTF C.loc, we say gene A. So this is going to return any rows where the row name is called gene A. So because intermediate ID is not a column name that's set yet, it will just create a new column there, and that's going to have input anything from here. So what I want to do is isolate. I need to go back to this. So I want to isolate basically everything after this to start with. So first I'm going to grab everything from here onward. And then of that, I'm going to just grab this part. So what we can do is take that metadata column, which was column 8. And then if we, so this is called function chaining, is something that you can do in pandas where you can say, take this, so column 8, and then use the string function. So that's going to convert these items into, or each element from that series, from the data within that column, to strings. And then for each of those strings, split up that string by a given delimiter. So if I were to just run this part, or I guess this part here, this would return the column where intermediate ID would be a list for each row with basically that string split up into as many items as there were this string. So since this string is only found once, it's basically going to take this and say anything before this, which is nothing, make that element 0 in the list. And then anything after that will be element 1. So then if I again convert that to a string, and this is just for pandas interpretability, and then take element 1, so index 1 from that list. So then all of the items here will be basically what's highlighted there. And then we can do a second step where we make a kind of a final column, which is ID. So we're going to take that intermediate ID, which is what's highlighted here, use this string to split as we did here. And as you'll notice here, so this exact string is actually found multiple times in here. So we're going to get a list of X number of elements that are basically breaking it up, breaking this string up at all these items. But since we've already removed this section, we're going to be looking for index 0 here. And so that will give us a nice and clean gene ID as this column here. So now we do the same exact thing, the same exact process, but instead we're going to be first splitting on this string. So then we'll get everything after that. And then afterwards we'll split on this string and get anything before that. And then we want to convert this to a dictionary format. So we basically want it to look something like this, where dictionary, we'll say gene ID 1 equals gene name A. But this will basically apply this function where we're matching these two pairs for every row of the data frame. So, and this is a little bit, I would recommend maybe reading the documentation for this function. So if we were to look up pandas.series, this will explain more exactly what this is doing. But basically it's, what we're doing is grabbing only that column called gene ID and setting that equal to the index, so the key basically, and then getting the values from the name column, and that's what each of these indices will be equal to. So that's what all of this is going to do. And then at the end, with that output, we're going to chain that to the toDictionary function. And so this will give us a nice clean dictionary with just the gene ID column and the gene name column formatted as keys and values that we can access like a normal dictionary. And at the end of that, we will return that gene dictionary after it's been formatted. So I'm going to pause here again. If there's any questions or anything's not clear, let me know. And I think this will be something too. I think it would be a good idea with some of these things. Maybe before you read all these into functions, you can just run these in Python and look at the output of the data frame after each step so you can see exactly how each of these steps are working. So now we have that gene dictionary. We have the user's data frame. Oh, is type ID user input. So in this script that I wrote, I didn't specify type ID to be a user input. This is more just so if I want to call this function multiple times in the script, I can just give a different variable here in the function. But I could also, back up here, require 3 user arguments, 2 for the 2 files, and the third would be that type ID. And then in the command line, someone could specify, oh, I want to make a gene dictionary using transcripts. And then that would be read in as argument 3. You'd return it from this function. And then that variable that you read in, you could then provide it as type ID when you call this function later in the script. Okay. So now we want to map so index is basically the name for a row name. So I want to map the row names from the data frame using that gene dictionary. So here I'm going to read in or have as inputs the data frame and then that gene dictionary that we just made. So again, I'm going to copy that user data table with those gene count values, make that a new variable. And then here, what I'm going to do is, so I want to basically set a temporary column again in the data frame. So I'm going to call this one new name. I'm going to take the index. So here it's referencing the data frame. From that, it's grabbing the index element. So those row names. Then we want to convert those row names to a series. So something that pandas, it's just a pandas data type that it can use to map a dictionary to those index values. And then we'll provide the map function with the gene dictionary as the input. So that's going to take basically that gene dictionary, look in the row names for any dictionary key that matches the row name, and then remap that with the dictionary's value instead. So when you do this using the map function, if it can't find a match of a row name to a dictionary key, it's going to put a not found value. So just not a number, not a string, just a null value. But we don't want null values as row names in the final data frame. So what I'm going to do is basically take that new column that I made with the mapped IDs, and then I can use this data frame function called fill NA. So this is going to fill any NA element with the original index. So I'll remove all those null values and replace it with the original value. But again, these new names are still set as a column. We want to basically set that new column that we made equal to the row names. And so what we'll do is use the set index function. So this is going to take as input a column from the data frame and basically remove that column and instead set that column equal to the row names. So we just give it the data frame name with that set index function, give it the column name, and then those new names will be set to the index. And then a note here, so this is going to give the data frame kind of a weird formatting when you do this. Basically, it's going to give it like a row name for a column name kind of thing. So basically what you can just do is run this command, and this will just basically remove that index column name. So at the end, we'll have the data frame with the properly formatted row names. We can return that new modified data frame, and then we'll move on to our last step, which is to take that modified data frame. You'll notice here that I'm not calling that data underscore C here. I'm just calling data because basically it's going to just, within this function, it's only going to reference whatever variable was put there. And so this is just kind of a generic variable name that's mapped to whatever component you put in as argument 1 to this function. But then I'm also going to give it that original data frame file path so that I can modify the original file name and output the modified data frame using that modified file name. So first I'm going to modify that file name. So I'm going to say, again, using that split function, you'll notice here I don't have to use that .str to format this as a string because this is already formatted as a string. That was that data frame path. So I'm going to say split it at every period and take the first item. So everything before the period, which is assumed to be, so let's just do this real quick. So if I were to say file.txt s.split at the periods, this is going to give me a list with basically split up at every period. So the file name is going to be everything before the period, and then the file suffix will be everything after the period. So here you see I basically run that split function twice. The first time I say output name is that first element or the file name, and the suffix is that second element. And then with the name that I'm going to save this data frame as, I'm going to say the output name here, so the original file name, plus we're just going to add to the end of the file name underscore renamed. And then because the splitting removed the periods, I'm going to add that period back. And at the end, I will add that suffix again. So at the end, if we had been using something like this, we would get as output file underscore renamed .txt as the new file name. And then with this function, so we use that data frame variable, which is data, use the to function on that data frame. And then with this, the only variables that we need to deal with are the output name, which we defined here. And then this will by default output the data table as a comma separated table. But as I mentioned before, I prefer not to use comma separated tables just because some G names have commas in the G name. And so that can throw off the formatting in the table. So instead, you can alternatively provide sep equals that special character T for a tab. And so this will output the file as a tab separated file. So now we want to link all of these functions together so that the user provides the two file paths. It goes through each of these functions to perform all those tasks, which will, in the end of the script, output that modified file name. So this is normally referred to as the main section of the script. And so you'll notice that there's no functions being called here. And so anything that's not within a function, that's going to automatically be run when the script is run. So before, whenever we ran or defining these functions, it's reading the function into memory to be able to be used within the script, but it's not actually executing that function yet, which we're going to be doing down here. So here I get those user inputs from the arguments. I read the GTF data frame from the file, read the gene count data from the file. I create that gene dictionary using the GTF. And here I didn't use that optional type ID variable here because I'm fine with just getting okay, so a question of slide 9. Oh, slide 8. Can you skip the tab symbol by making it a tab delimited file in a previous step? Instead of CVS, can't you save it as a tab delimited file? So the file name itself right here is TSV. But when it's actually reading, so I can basically create a comma separated file, like where the input, the actual file is comma separated, but force it to be saved as a TSV file. So just specifying a TSV file name here wouldn't be enough. That's why you have to specify the tab delimiting step there. Does that make sense? Or does that answer that question? Okay. Okay, so we make that gene dictionary. We map that gene dictionary to the data frame, and then we'll have that modified data frame, and then we will output the modified data frame as a tab delimited file where we just modify that original input name by just adding that underscore renamed at the end. So then if we were to run this in the command line, we would say Python script name. So I called this gene underscore dictionary.py. So again, any Python script is going to end in .py. And then we'll just specify those input files, separating them with a space. So that first one was the GTF file, and then that second one was the data frame file. And just as a note, so if you want to write the script and test it and you don't have your gene counts yet from the previous class, within the GitHub repository for this lesson, I have a sample data table that you can use, but you will need to download that, in this case, the yeast GTF file to be able to test this. So then, like I showed you before, I specified at the beginning when I was parsing the arguments to just print out what's the script name, where are the options being run, It runs, we don't see any errors, and in this case, it output that renamed data table where instead of gene IDs, it had the remapped gene names wherever it could find a gene name. So the task for this would be to basically do exactly what we went over today, but again, try to do it on your own. Try to kind of troubleshoot through each step, even if you need to like copy a command, at least try to interactively test that command in Python and see what exactly that step is doing. And say maybe you're getting stuck on a step, so you're running the script and you want to see what an intermediate data frame looks like. So maybe it's better for me to just open up my actual script real quick. Ooh, I don't want to open it with that. Okay, works. So say here, when I was grabbing just the rows where that column was gene, and I wanted to make sure that I was getting the right output when I was testing the script, here I could just write print. So this will print to the command line output. I can say GTF underscore C, but I don't want to print out the whole data frame. That's just going to overwhelm the command line. So we can use, this is similar to the command line function that was head. If we want to run head on the data frame, we would say dot head parentheses. So this is kind of called the head function on that intermediate data frame. And so we'd be able to see just the first, I think Pandas only displays the first 5 lines using head. If you want to modify that, you could just put maybe 10 inside the parentheses of head. So kind of see what each step is doing, what each step of the output is looking like, see if you're able to create your own gene dictionary script. And again, feel free to ask me if you have any questions along the way. And the example data table is SCE underscore data table underscore table dot, I think it's TSV. So here's the folder. That dot DS underscore store. So that is, you'll notice that file starts with a period, so that's a hidden file. So if I go to here, so I am printing out currently all hidden files too. So it's kind of annoying that it creates this file, but if I were to just read this file, it's basically metadata of the folder for the Mac operating system. And I forgot to tell GitHub to ignore those hidden files. So that's just what it is. You don't need to worry about that file. It's just kind of a metadata file that Mac uses. Okay. Any other questions about what we went over today, or even things from previous classes? Okay. Well, I will just wait for everyone to sign off then. If you have any questions, feel free to ask them. But if not, I will see you all on Wednesday.
Hey, Jordan.
Yeah.
Hi, this is Surbhi here, and sorry, like I think I still have stuff from like last classes.
Yeah. No
So
problem.
I don't know if I should discuss it right now, but so I was having trouble with my CHPC account and with the amount of data and everything.
Yeah.
So what I did was like, as you told me to move the stuff to the Scratch folder.
Yeah.
So what I did was like I actually moved and then deleted it, and as I thought, like my previous data set was like 56 GB, and the data set from East that you were having was almost a similar size in the end. So I
Okay.
went ahead and re-downloaded everything, and during that process I actually put the output directory as the Scratch folder, like like
Okay.
Scratch, like I mean to say Lustre Scratch Lustre and then my UID.
Okay.
And then uh, there I was, it just like looked like it was going fine, and then suddenly during the last FASTM file I got like a big, like I don't know, it's like 6 7 5 6 pages of error which I really cannot understand. Basically everything terminated and it says like your disk quota exceeded 122, but then when I checked my disk quota by giving the command, it still says like I have used 38 GB out of 50 GB, and
Okay.
I don't know what's, it's like it's so weird, like I'm stuck at that step and can never go past that.
So let me look at your. Oh, I see. Okay. I think I know what happened. Okay. So somehow you copied your entire Scratch directory back into your home directory.
Huh?
So if you go to your home directory, I can just show you this real quick. So in your home directory, you have this Scratch directory here.
Yeah, and it has a folder, it has thing called general, right?
Yeah, so if you go, just keep on going down the folder. So I go in general, then Lustre,
Uh-huh.
UID here. And so
Uh-huh.
it just basically copied all of your FASTQ files back to your home directory.
How is it?
So what you need to do is, so you have to use /scratch. So you don't want the tilde in front of it. You just want -scratch dash Lustre dash general dash your UID.
So this is dash, not this tilde sign, like backslash
Yeah.
/ sign.
Yeah, so if whenever you use that tilde, it's going to reference your home directory. So it's just putting all this back in your home directory.
So
So what you'll
CD.
have to do, since you don't have this Scratch directory
Uh-huh.
created yet, you need to just run make directory that.
Okay.
So I'll Slack that to you.
But like, okay, when I did mouse index, mouse genome index, and in the for the output path, I gave this Scratch directory path. It went there, right? And it made that directory mouse underscore index. So how come that go there, but when I do it for these files, this did not go there?
Let me take a quick look at your script. So is it the ref mouse is how you built it?
No. Okay, which one for this FASTM thing?
How did you, what was the script that you used to build the genome index?
Okay, that was reference underscore mouse genome.sh.
Okay.
It doesn't say anything?
No, it looks
Weird.
like it's
Maybe I
empty.
might have. Okay, then this should
I'll
have
try
been the
this.
one.
Ref mouse.
.sh, maybe. Yeah. Sorry.
So this is downloading the intermediate files. Process. Yeah, for some reason your
Sorry,
scripts are.
sorry, no. The script is build_mouseindex.sh.
Okay.
It should be there.
Yeah, okay, this looks good. Okay, scratch directory.
Yeah, it went in there and it made that folder for mouse index, and everything was fine because you like we checked the log.out file and everything was there. But for this
Okay.
for downloading the new SRA files and then FASTM stuff for the FASTQ stuff, I actually use this script like SV download underscore GSE149443 sec.sh, and this script it's this script which has given all that. So you see in the output directory, I gave the address of scratch, general luster, my UID, and then the file name.
So see how there's a tilde in front?
Yeah.
So you need to remove that because it's looking in your home directory right now. So you need to just delete that tilde.
Oh, so then it'll go to the scratch folder.
Yeah, because right now it's not finding, like before you had run this, it didn't find that scratch directory. And so it created the scratch, this file path within your home directory.
Okay.
Yeah.
That's what I did. So I then I can remove the scratch directory from my home directory, right? I should remove it.
Yeah.
The whole folder saying scratch.
Yeah, and then you should have plenty of space in your home directory.
And then I can rerun. Yeah, then I can rerun this script and then do all the steps.
Yeah.
It should automatically create in the scratch directory then.
Yeah.
Okay.
Yeah, it looks like, yeah, your script looks good. So just once you remove that tilde there, I think that script should be good to go.
Okay, so it's automatically connecting it to my home directory. Okay. Yeah, because I got such a big, like 5-6 pages of error. I was like, what am I doing? I don't know.
Yeah. Yeah, I'm guessing that's where that was coming from.
Yeah, so and how much space do we have in scratch directory?
Technically unlimited. So, but it is shared with other people. So it's good to clean it up after you're done with it. But I've frequently ran a data set that produced like a terabyte of data.
Okay.
And so I was able to hold it while I was running the job and until I downloaded the files that I wanted. And then after that was done, then I removed that scratch directory. Not my scratch user directory, but just within my scratch directory, the directory that was made for that specific job.
Yeah, I think that should be fine now because I got a nice email from like CHPC saying that I'm running a computationally intensive work on an interactive node.
And and that could be because you're transferring a lot of files between locations.
Okay.
So, but
hopefully,
if you're running that as a bash script, I think that script should be fine as you have it once you fix that tilde.
Okay, so I'll just delete that scratch folder and then fix the tilde and redo the stuff. And hopefully things from there should be straightforward. Yeah. Okay. Thanks, Jordan. Sorry,
Yeah.
I keep bugging.
No problem. Glad that you have lots of questions. It's good.
Yeah, thank you.
Okay. See you Wednesday.
See you. Bye.